Okay, the last section that I wanted us to cover in Chapter 11 is 11.3, which is called determinants. There's a definition that says the determinant of a 2 by 2 matrix is D equals A times D minus B times C. You're going to cross multiply here. The notation for a determinant is where you want to use straight lines. We talked about brackets for when you have a matrix. This is not a matrix, okay? A determinant is different. Now you're using a matrix to calculate a determinant, but D is not a matrix. The determinant of a 3 by 3 matrix would be D equals the following, where if you break it down, okay, you're going to use the top row here for these coefficients. You're going to take A sub 1, 1 times the determinant for, I'm going to kind of block out what we're doing there, and here's my determinant that I'm going to be multiplying A sub 1, 1 by, and then minus A sub 1, 2 times the next determinant. You're going to block out, basically you're blocking out row 1 and column 2 here, and then plus A sub 1, 3 times the determinant where you're going to be blocking out row 1 and column 3 to get this last determinant. Okay, the signs will alternate positive, negative, positive, and think about it as, you know, whichever multiplier you have, you're going to be blocking out that row and column to get the determinant multiplier. Okay. I'm using subscript notation here to indicate the row first and the column second. So here's an example. We're going to calculate a determinant. So with the 2 by 2, all you do is just simply cross multiply. It's going to be 8 times 2 minus negative 3 times 4, and that gives you 28. A determinant will always be a single value when completely simplified. Here's another example. I've got a 3 by 3 determinant that I'm going to calculate. So according to the formula that I had written from above here, I'm going to apply that. I want 4 times the determinant for when I block out row 1 and column 1, and so I've got that determinant written, and then minus negative 7, again the signs have to alternate here, times the determinant for when I block out row 1 and column 2, and you can see those numbers that we're forming there, plus 8 times the determinant for when you block out row 1 and column 3. You can see how I'm getting that last determinant. Okay. With these 2 by 2s now, again, you're going to cross multiply. So 1 times negative 1 is negative 1, minus 3 times 3 is 9, and then in the next one, 2 times negative 1 is negative 2, minus 3 times negative 6 is negative 18, and then in the last one, 2 times 3 is 6, minus 1 times negative 6 is negative 6. When you simplify, you should be getting 168 then, is what I was getting there for the determinant. Okay, now why do we have determinants? Well, the topic is still solving systems, and Kramer's rule says the solution to a system here, this is a 2 by 2, is given by x and y, where you're taking a determinant divided by a determinant. Okay, I'm going to let capital D sub x be the determinant in the numerator for when I get x, and then capital D sub y be the determinant for when I get the numerator in getting y, and then D sub z would be, if there's a third variable, that'd be the numerator for getting the variable z. D is going to be represented by the determinant that would be in the denominator here, which is going to be the same for each value that you're calculating. Okay, now one way that I like to remember how we're getting the numerator determinant is whatever the subscript value is, you're just going to simply move the coefficient column over to that variable column. the other column will stay the same. Okay, so d sub x is just where I'm sliding the coefficient column over to the x column. D sub y would be where I'm sliding the coefficient column over to the y column. Okay, a d sub z would be where I'm sliding the coefficient column over to the z column, etc. Here's an example. Okay, so suppose that we want to solve this system by using determinants. We got to calculate d sub x, d sub y, and then d. D is the determinant using only the variables that are in front of the or the numbers that are in front of the variable columns. Okay, so I got a 7 in front of x, a 4 in front of y, here's a 11 in front of x, and a negative 5 in front of y. Cross multiply that. 7 times negative 5 is negative 35. 4 times 11 is 44. You're subtracting. Be sure that you subtract. Some students accidentally add these numbers and then they got the wrong answer. So negative 79 would be in the denominator here when I eventually find x and y. D sub x would be where I take the coefficient column and then slide that over to the x column and form the determinant that you see here. Cross multiply that. 23 times negative 5 is negative 115. Minus 4 times 70 is 280. Negative 395 would be the value of d sub x. Okay, d sub y would be the determinant for when you slide the coefficient column over to the y column. And so here's that determinant formed. Cross multiply that. 7 times 70 is 470. And then 11 times 23 is 253. When you subtract, you get 237. Okay. X is where we take d sub x divided by d. We found those numbers there, and you get 5 when you simplify. Y would be where you take d sub y divided by d. And again, we found those numbers. We get y equals negative 3. And of course, I could check those if I wanted to, like I could any other system there. Here's another example. So this is using a 3 by 3. We're going to use Kramer's rule, or determinants, to solve for to solve the system. So in this problem, I'm going to have to find d sub x, d sub y, d sub z, and d. Okay. D sub x would be where I slide the coefficient column over to the x column. And here would be the determinant formed from that. When you break that down, you're going to want negative 1 times the determinant resulting from when you block out row 1 and column 1. And I've got those numbers there that you see. Minus 2 times the determinant that would be formed when you block out row 1 and column 2. That's how I'm getting this determinant with those numbers there. Plus 3 times the determinant for when you block out row 1 and column 3. And you can see the numbers that would be formed to get that last determinant. So now that we've broken that down to some 2 by 2's here, cross multiply. Negative 3 times negative 2 is 6. 4 times negative 1 is negative 4, but you're subtracting negative 4 though. Okay. Minus 2, again, make sure that you alternate the signs here. Okay, this goes positive, negative, positive. Some students mess up that middle sign there. So it's going to be a minus 2 times 12 times negative 2 is negative 24. Negative 12 times negative 1 is 12. Okay, and then plus 3 times 12 times 4 is 48. Minus negative 3 times negative 12 is 36. And we're getting, let's see here, 98 would be the value of d sub x. D sub y then would be where I take the variable column and slide it over to the y column. Alright, so here'd be the coefficients formed from when you do that in this determinant. And again, working with breaking this down here, so we're going to have 1 times the determinant found by when you block out row 1 and column 1. And then it's going to be a plus 1, since we're changing sign there, times the determinant found by when you block out row 1 and column 2. And then minus or excuse me, plus 3 times the determinant found by when you black out row 1 in column 3. There, whoops. So you can see the last determinant there found. Okay, simplify that. And you got 1 times 12 times negative 2 is negative 24, minus negative 1 times negative 12 is 12, plus 1 times 2 times negative 2 is negative 4, minus 1 times negative 1 is negative 1. You're subtracting negative 1, so that means you're adding 1. Plus 3 times 2 times negative 12 is negative 24, minus 1 times 12 is 12. And when you simplify this here, I'm getting negative 147 then. Okay, d sub z would be where I take the coefficient column and then slide it over to the z column, and then write down the coefficients there. So here's d sub z formed, and I want to break that down now. So I'm going to have 1 times the determinant found by when you block out row 1 in column 1, and then it's going to be minus 2 times the determinant found by when you block out row 1 in column 2, minus 1 times the determinant found by when you block out row 1 in column 3. Okay. Simplify that. So 1 times negative 3 times negative 12 is 36, minus 4 times 12 is 48. Minus 2 times negative 12 is negative 24, minus 1 times 12 is 12, and then minus 1 times 2 times 4 is 8, minus negative 3 or plus 3. Okay, and I'm getting 49 then when you simplify that. D would be the determinant found by just using only the coefficients on the variable columns. Okay? And so here'd be that determinant that we've got. Simplify that. So you're going to have 1 times the determinant found by when you block out row 1 in column 1, and then minus 2 times the determinant found by when you block out row 1 in column 2, and then plus 3 times the determinant found by when you block out row 1 in column 3. Okay, simplify that. So we have 1 times negative 3 times negative 2 is 6, minus 4 times negative 1 is negative 4. You're subtracting negative 4, so that means you're adding 4. Minus 2 times negative 2 is negative 4. Minus 1 times negative 1 is negative 1. You're subtracting negative 1, so that means you're adding 1 there. Plus 3 times 2 times 4 is 8. Minus negative 3 times 1 is negative 3. You're subtracting negative 3, so that means you're adding 3. When you simplify, you should be getting 49. Okay, so now that we've got d sub x, d sub y, d sub z, and d found, we can then find x, y, and z. X is where we take d sub x, which we said earlier was 98 for d sub x, and we're going to divide that by d is 49, so I get x equal 2. Y is where I take d sub y, which is negative 147 for d sub y. I'm dividing by d, which is 49, so I get negative 3 for y. Z is where I take d sub z, which is 49, divided by d, which is also 49, and so z is 1. Okay. That is it for chapter 11 that I want to cover. So we are now done with the algebra part of the course, and moving on in the notes and the videos, we're going to begin doing trig then.